Hi everyone, today we will see the frictional force. When a external force is not applied on the body cannot move. When we apply the external force, the body will move in the direction of the force. But another force will work in the opposite direction of the moving body, that is called frictional force. Frictional force will work in the opposite direction of the move of a body. If a body will move in, suppose M body is moving in the frontward direction, then the frictional force will work in the opposite direction of the motion of the M body. Means frictional force will work in the backward direction of the move body, or will work in the backward direction of the external force. Okay, if a body is in stationary position by working of the frictional force, if the frictional force is not work, then uh, the body will slip down and move according to the force. We walk uh, due to the frictional force. If frictional force not work, then we can slip. Okay, frictional force, this is called static frictional force, as uh, this is called static as the body not move. This is why it is called as static frictional force. If the body move, then a frictional force works, that is called as the kinetic frictional force. Understand about the static frictional force and kinetic frictional force. When a body move, a frictional force works, that is called as the kinetic. When a body is in rest position or in stationary position, then it is called as the static frictional force. And frictional force is equal to mu s n. N is the normal reaction that will work in the opposite direction of the weight of the body. The weight of the body is always in downward direction toward the gravity of our earth, and a normal reaction is always in upward direction of the upward direction, is opposite to the weight of the body, that is called as the normal reaction. And this is the coefficient of the friction, that is called as coefficient of the friction. This is static coefficient of friction. When a body moves, then this is called as the kinetic coefficient of friction. Okay, normal reaction is equivalent to mass, weight of the body, mass into gravity. Normal reaction is mg, and frictional force is equivalent to coefficient of friction and the weight of the body. That means mu mg. That is called as the frictional force. The body is in stationary position, that is why it is called as the static frictional force. Okay, we can see the body is in the stationary position in a elevated angle. The the elevation is in angle theta, and body is in the stationary position. The body not moving, it's in rest position, and we will see a normal reaction is perpendicular to the body, and also mass is the weight of the body is downward, that is called as the weight of the body, and mg, and angle is theta. That's why normal reaction is balanced by mg cos theta. And another component is working in horizontal direction in theta angle, that is called as the mg sin theta, and frictional force is working in the opposite direction of the uh, mg sin theta. That's why the body is in stationary position. If uh, external force is more than the frictional force, then the body will move downward. Normal reaction equals to mg cos theta, and normal reaction is equivalent to or equals to mg cos theta, and frictional force is equals to mg sin theta. Then frictional force, we know frictional force is coefficient of friction into normal reaction. Mm, then mg sin theta and mu mg cos theta equals to mu mg cos theta. Then we can solve tan theta equals to mu. That means coefficient of friction depends upon the angle of elevation, and the uh, frictional force also depend upon the mass of the body, but does not depend upon the area of the body acquires the area. Does not depend upon the area but depend upon the mass. Okay, then theta equals to mu. This is means the coefficient of the friction depends upon the angle of elevation. Okay, next we will go to see a problem. A 20 kg mass is moving towards the pulley, and also 3 kg mass is hanging. In the question it has asked what is the tension in the string. We can solve 3 kg mass is hanging, that's why uh, mg is 30 newton, and mm, a force is in opposite direction of the weight of the body in the string will create, that is called as the tensile force. And that asked what is the tensile force. Mg is 30 newton, and in the moving body we can see in 20 kg mass, uh, mg is its weight of the body mg, and this is 200 newton. 20 into 10 equals to 200 newton, and a normal reaction also works in upward direction. mg will balance by the normal reaction, and a frictional force will work in opposite direction of the moving moving body. Then the coefficient of this is called as the kinetic friction, as kinetic friction, and this is coefficient of a kinetic coefficient friction. We can see that has given coefficient of kinetic friction is 0.04, and frictional force we can calculate mu k n equals to we put the value, then we will get 8 newton. Then we can calculate by using the equation. We will get two equations from the mass 3 kg and mass 20 kg. We will get two equations. That equation will work to solve the problems. In 3 kg we will calculate in that way. Mg is 30 Newton. That means the body 3 kg is moving downward. That's why 30 is the mg minus tensile force equals to ma. Ma means 3 kg into a. And in the second equation we can see the tensile force uh, will taking the body towards right hand towards the pulley, and this tensile force minus frictional force equals to 20. 20 means mass of the body into acceleration. Then we can add the uh, frictional force is 8. We have calculated frictional force is 8 Newton, and we put the all data and then we add the two equation, then we can get A equals to 22 by 23 Newton meter per second square. Then we can get the tensile force, putting all the values, then we will get tensile force. Thank you. We will solve many difficult problems, and next time we will solve our more problems to see how many tricks will be used. Thank you.